But here we have types of observational studies. Last week we talked about the difference between an observational study and an experiment. In an observational study, we are just looking. We're not manipulating. We're just observing. And so there are three different types of observational studies. There's the cross-sectional study, the retrospective or case control study, and also the prospective or longitudinal or cohort study. Okay, so with the cross-sectional study, we're looking at data at a certain period of time. Okay, data is looked at or studied over a certain period of time. And I shouldn't say period. Look at data at a certain point. In time. Okay. For instance, suppose we're interested in getting some information about the number of parking spots that we need here on campus. And so we might, at the beginning of each month, look to see how many cars are in the lot at a particular time. Okay, so that's cross-sectional. We're looking at data not along and along necessarily, but at a particular point in time. Okay, with the retrospective study, we're looking back in time to collect our data. Okay, we go back over some period of time. Okay, looks back. Again, some of the things about the observational study is that this is the only way we can collect data where it might be unethical for us to conduct an experiment. So with the retrospective study, people naturally choose their behaviors. I think I might have said that already. People choose the behaviors that they're going to have, whether or not they want to smoke or have healthy eating habits or exercise. And so we look back. Usually there's some end result we're interested in, like let's say heart disease or something like that. And so you start asking people, well, did you exercise on a regular basis? Did you smoke? Did you blah, blah, blah? It goes on and on. But they have to think back to what they've done. Okay, so people naturally choose what it is they want to do. It's a retrospective study. We call it a case control because we try to find people who also did not have those behaviors so that we can determine, whether or not smoking or whatever it is really leads to whatever outcome we're looking at. Does that make sense? Okay, that's the retrospective study. And then the prospective study is we follow a group of people over a period of time. I mean, some of these studies can last for years. Follow a group over a period of time. And I really liked this flow chart that they had in the textbook. I thought it was really good for helping you decide if something really is an observational study, what type of observational study it might be, or if it's an experiment. Okay, so we probably have some examples. Let's see if we can answer these. Or did I not have examples? Okay, on the very last page. Starting right. Okay, all right, let's go ahead and talk about these. Okay, indicate whether the observational study is cross-sectional, retrospective, or prospective. Okay? In order to study the seriousness of drinking and driving, a researcher obtains records from past car crashes. Drivers are partitioned into a group that had no alcohol consumption and another group that did have evidence of alcohol consumption at the time of the crash. What type of study would you say that this is? Retrospective. Very good. Okay? We were interested in factors that lead to a car crash. And in particular, we want to know about the effect of alcohol on car crashes. So we got a whole bunch of data from car crashes, and then we were able to say, okay, got the crash, now we can look back and ask, was there alcohol involved? Okay, can't do an experiment that says drink and then now go out and drive. So we have to rely on the retrospective study. I didn't say retrospective studies can be a little funny. because you almost always have to rely on reported results from the person, and people forget. Something that I used to be very interested in is artificial sweeteners. I had to swallow, excuse me. And I can remember, I can't believe this. I can remember in college when NutraSweet started coming out, people were very leery of it, right? So if you ask me today, 20 years later, about my habits of, consuming artificial sweetener, I can't tell you. I didn't know somebody was going to ask me about it. I didn't take notes. So the problems with the retrospective studies, sometimes people, they just don't remember, or we've got those reported results, so they might fudge the answers. Okay, researchers at the National Cancer Institute studied meat consumption and its relationship to mortality. Approximately 500,000 people were surveyed, and then they were followed for a period of 10 years. What is that? Okay, prospective. Very good. All right, we're following them over this period, okay, or cohort study. Okay, then the Nielsen Media Research Company uses people meters to record viewing habits of 5,000 households, and today those meters will be used to determine the proportion of households tuned to CBS Evening News. That's going to be what? Cross-sectional. Very good. Cross-sectional. All right, y'all got that. Excellent. Okay. All right, now we got some information about experiments. And they had a very interesting study on page 28 in the textbook. I didn't write it here, but just as we think about these things, let's take a look at that. It says in 1954, a large-scale experiment was designed to test the effectiveness of the Salk vaccine in preventing polio, which had killed or paralyzed thousands of children. In that experiment, 200,745 children were given a treatment consisting of Salk vaccine injections, while a second group of 201,229 children were injected with a placebo that contained no drug. The children being injected did not know whether they were getting the Salk vaccine or the placebo. Children were assigned to the treatment or placebo group through a process of random selection, equivalent to flipping a coin. Among the children given the Salk vaccine, 33 later developed paralytic polio, and among the children given a placebo, 115 later developed paralytic polio. Okay, so some things, this gives us a point of reference, but some things we want to talk about have to do with randomization. Okay, randomization is when we use a random process to assign people to the various treatment groups. Okay, so that's what they did here. Use a random process. All right, also we can talk about replication. And here, the author, I learned, was just talking about repeating this process on a large enough number of people. They didn't just pick one person and give them the treatment and one and give them the placebo. They used a lot of people, over 200,000 in each group. Sorry. Replication can also mean repeating the experiment more than once on your whole data set. Okay, just because you got these results where it looks like the vaccine was effective, this time if we repeated this, we get those results again. Okay, so replication can talk about repeating it on more than one subject, or it can talk about repeating this entire process. I'll give you another example of replication that has resulted from some of the projects. One thing that students are often interested in is which grocery store has the best prices. And so, usually we're kind of rushing to get our data. And so a lot of times students will go to the grocery store one time. We're going to Bi-Lo, Publix, and Walmart this week. Okay? And one of them might come out, they get the same product, same brand, same size and everything. And let's say Bi-Lo comes out to be cheaper. Well, is it going to be cheaper next week? Maybe not, right? So they didn't have replication in their experiment. So repeating this experiment more than just once, is important so that we can get sufficient results. Blinding. Blinding happens a lot in experiments where the subject doesn't know which treatment they've received. And we kind of count placebo as a treatment. Why is that important? I think we talked about that already. Okay, prevents bias, or okay, the subject might act like they feel better or whatever. Okay, so we don't let them know whether they're getting the real thing or a sugar pill. And so that's what we call the placebo effect, is when subjects act as if the treatment is effective. Whether it really is or isn't. Okay. Okay, very good. That's the placebo effect. And then we also can talk about double blinding. Double blinding is not only is the subject who's receiving the treatment, they don't know whether they got the treatment or the sugar pill, but the person who's interviewing or observing them also doesn't know. Okay, so subject doesn't know. Subject and researcher will say. They don't know which treatment is applied. Okay, why do we need to do double blinding? Okay, all right, the experimenter can create bias, especially if they're going to benefit from reporting certain results. I've got a new pill that hopefully will shorten the length of your cold, and I'm going to ask you, are you sure you don't feel a little bit better? If I know you took the pill or whatever. So double blinding prevents that. Okay, we aren't leading on the subjects when we're questioning or observing them. Okay, very good. And then completely randomized experimental design. Okay, let's look at some of these. I want to make sure I get these right. With confounding, we have one variable. Okay, occurs in an experiment when the experimenter is not able to distinguish between the effects of different factors. And that, I'm glad I looked at that because I did a really poor job of explaining that. And so when we design an experiment, we need to design it in such a way that we're not unclear about the effect of something on the outcome. For instance, let's say we're interested in deciding whether or not students learn better in an online environment or in a traditional classroom environment. Okay? And let's say in my experiment I assign all of the women to the online class and then all of the guys to the classroom. Okay? And then at the end of it I say, you know what? Classroom learning is better. Okay? Well, can I really say that? No, because we've got that confounding there. There's this whole variable of gender that we're not even addressing because of the way the experiment was created. So that's what we mean by confounding. All right, occurs in an experiment when the experimenter is not able to distinguish between the effects of different. Because of the way that experiment was designed, we can't tell whether it was the face-to-face versus online or the male versus female. Well, I think with the lurking variable, it relates more to just the variable, whereas confounding is part of how we design an experiment. Okay, so because of the way the experiment is designed, which was, a bad way, then we can't tell whether, it's the face-to-face versus online or the gender or something else. Okay, and we'll look at some examples of these in just a second. Very good. Okay. Let's see. Then we were going to talk about completely randomized experimental design. And since I got that here, let's go ahead and use it. Okay, when we talk about completely randomized experimental design, we assign subjects to different treatment groups through a process of random selection. And then we've got the randomized block design. A block is a group of subjects that are similar, but blocks differ in ways that might affect the outcome of the experiment. So in the illustration there, next to those definitions, you'll see where we have a randomized block design. Okay, let's look at that together. I'll give you a second to write that down. All right, so with the randomized block design, we've got a group of subjects that are similar, or we block them according to their similar traits like gender. All right, then we're going to apply, if you're looking at the image there, you're going to apply the treatments within the group. Okay, so within the block, we randomize. Does that make sense? All right, and I'm looking at image C on the handout there. Okay, we separated them out by men and women. And then we pick some to receive the treatment and others would receive the placebo. That way, if there is an effect on men versus women, we can figure that out as well, along with the face-to-face versus online. Okay? Matched pairs design. In a matched pairs design experiment, we try to find subjects that are alike on the key points. For instance, again, if we go back to something like heart disease, okay, and I've got a person who is going to take an aspirin every day and somebody who's not, then I'm going to have, a female, 32 years of age, if we're talking about me, same height, same weight, same factors, okay? Same eating habits, exercising habits, those kind of things. That's what we call a matched pairs design. Does that make any sense? Okay, good. All right. Now, the easiest way to get a matched pairs design is, if it's possible, to use yourself as a matched pair. Okay. For instance, let's say I want to know the effect of Dansko shoes on my knee pain in classroom. Okay, so I could, let's say we give them to all the teachers, everybody gets some. Then for like 6 weeks, we can let people go around in whichever shoes they prefer, right? And then ask them how they feel, and then let them wear Dansko shoes for 2 or 3 weeks, and then evaluate again. So each person is their own matched pair. I don't have to worry about going out and finding somebody who's my height, my weight, my size, who's teaching the same amount of time that I do. I'm already my own matched pair. Does that make sense? Okay. Another easy way to get matched pairs is possibly from twins. Okay, that's very easy to do a matched pairs design that way. So in the image it says get measurements from the same subjects before and after some treatment. Okay, we could do that. Or if possible, if we have to, we can try to match people on the key factors. Okay? The rigorously controlled design. And let's see what they say about that one. Okay, carefully assign subjects to different treatment groups so that those given each treatment are similar in ways that are important to the experiment. I mean, that's a lot. It just takes a lot to you know, especially if you're doing a large experiment, to find, you know, all of those basically match pairs. Okay, so let's see if we can identify some of these things in the examples that I just passed out to you. And this will bring us to the end of chapter 1. Okay, in the examples, we want to identify. Well, actually, I kind of skipped over a little bit. Okay, let's talk about just a couple of other things, then we'll do the examples. Sampling error. Okay, sampling error occurs when there's something about the way that you're sampling that causes the error, or the way that the experiment is designed. For instance, remember the other day I was talking about the disposable baby bottles? You remember the liners? I didn't talk about that in here. When I was out for a semester, or I came in mid-semester, I'd had a child, and everybody for the final project did the disposable liners. Okay, all right. Well, let me tell you about that. So I just told you. I had a child, and I see math problems everywhere, right? So I came back, you know, late January or whatever, and just to make things easy, I had everyone do the same project. That wasn't my original idea, but while I was at home and I made this 24 ounces of formula, I've got 6 4-ounce bottles, and I poured in and I got some left over, really drove me crazy, okay? The math person in me was not happy. So, you know, I'm tugging and pulling, and no matter what, I always had like this little half bottle left over. So, by chance, I was in a dollar store one day and found some Dollar Tree disposable baby liner thingies. And I was like, oh, I got to grab these. So, you know, thinking about my experiment, not really caring about the child at the point. You know, I cared, but I was getting those for me. And so I wanted to know, are these going to be more accurate, you know? And so go home, and they did seem to open more freely, you know, but still had the same problem, still had some left over. So I got a question now. Do these things really hold, on average, 4 ounces at the 4-ounce line? And the other question was, does one hold more than the other? So when I came back, I had disposable baby liners for everybody. All right, we all were going to investigate this. And we had a lab down the hall here where people went to do math and experiments and things like that. And so I went into the lab one day, and people had the little liners blowing them up with their mouth and stuff like this. Like, wait a minute, okay? Why was that a problem? It's unsanitary, right? That's not how a mother would or father would use those liners. That's the first thing. And yeah, obviously, if you go ahead and blow it open, then it's going to hold more. So, you know, that could definitely lead to some problems in the way that we sampled or designed the experiment. Okay, that's sampling error. Okay, versus non-sampling error is really just kind of random error. Let's see what they say on the little thingy here. Okay. Non-sampling errors: sample data incorrectly collected, recorded, or analyzed, such as by selecting a biased sample, using a defective instrument, or copying the data incorrectly. That sounds like what I just described with the way they were doing the liners. Okay, that's our non-sampling error. Okay, sample data incorrectly collected. Somebody's vibrating. Okay. Versus the sampling error, let's go back to that one, is the difference between a sample result and the true population result. Such an error results from chance sample fluctuations. Okay, that's true. Okay. For instance, there is the average number, let's say the average age of students at Midlands Tech. But if I collect a sample of data, is that sample going to give me that true population mean? Probably not. Y'all following me at all? Okay. So in that case, that would be sampling error. That we expect that to happen. All right. And then there was one more, non-random sampling error. Went too far? This is our non-sampling error. Yes. Yes, they are in textbook. Okay. Non-random sampling error. Right. So with the non-random sampling error, you get error because you didn't use a random sample. Okay. Alrighty. Well, let's take a look at those examples now. I think that's where we are. Okay, we want to identify which of these designs is most appropriate for the given experiment. Completely randomized design, randomized block, or match pairs design. Okay. Lisinopril is a drug designed to lower blood pressure. In a clinical trial of lisinopril, blood pressure levels of subjects are measured before and after they have been treated with the drug. Match pairs design. Okay, we got that before, after going on, so that's definitely match pairs. Excellent. A clinical trial of aspirin treatments is being planned to determine whether the rate of myocardial infarctions, is that right, heart attacks, is different from men and women. Okay, what would you say? Randomized block. Okay, because in addition to knowing whether or not the treatment is effective, we also kind of want to know how it varies for men versus women. Okay, randomized block. Okay, currently there is no approved vaccine for the prevention of West Nile virus. A clinical trial of a possible vaccine is being planned to include subjects treated with the vaccine while others are given a placebo. Okay, completely randomized. Very good. All right, the HIV Trials Network is conducting a study to test the effectiveness of 2 different experimental HIV vaccines. Subjects will consist of 80 pairs of twins. For each pair of twins, one of the subjects will be treated with a DNA vaccine, and the other twin will be treated with the adenoviral vector vaccine. Match pairs. Okay, excellent. All right, in reference to the last example, who can tell us what blinding is and why it's important in this study? Okay, the subject doesn't know which of the vaccines they've received. Okay, and do you think that's important? Yes, okay, why? Okay, all right, determine how they act towards the effectiveness of something. Okay, interesting. Okay, all right, very good. I'll leave it as yes. Okay. Next example. In cardiovascular effects of intravenous trialdothorba in patients undergoing coronary artery bypass graft surgery, the authors explain that patients were assigned to one of three groups. A group treated with the tridothoronine, a group treated with normal saline bolus and dopamine, and a placebo group given normal saline. The authors summarized the sample design as prospective, randomized, double-blind, placebo-controlled trial. Describe the meaning of each of those terms in the context of the study. Okay, what does prospective mean here? Okay, we're going to follow the people over some period of time. Very good. Okay, randomized. Okay, assign them to the different groups through a random process. Okay, it's not like we're trying to find three people who we can consider a matched triple and put one of each. We're just randomly assigning. Okay, and if your sample's large enough, then it'll work out. You'll get some matches or whatever. Okay, talked about that. What about double blind? Okay. The subjects don't know which treatment they're receiving, and the people who are observing them, the researchers, don't know which treatment they've received. Okay, let's see. Placebo-controlled trial. I don't know if we talked so much about that today. I think we did last time. Why do we use a placebo? Or if it's just psychological, right? So that's what's going to. This is placebo control because we have one group that's getting what? Just the normal saline, right? That's there's nothing to that, right? Just a little salt and water or whatever. So that's the placebo. We need to have that so that we can truly measure the effect. Separate that from psychological effect. Okay, questions about that? Excellent. We made it to the end of chapter 1. Woohoo! Okay.